Unit 6, Biomechanics Numerical Model. This assignment looks at the numerical model of biomechanics and gives an insight of how this can help improve athletes' performance. The numerical model is a set of collected numerical data which can be used to look at and develop an individual or team's performance. It can help athletes and teams to improve and work towards set goals which will increase their performance, in this case becoming better at basketball and in particular rebounding. So biomechanics, which is the application of mechanics to the human body in relation to, in this case, sporting context, and in particular basketball, and the study of force applied on the human body and the results of these forces. This can be broken down into kinematics and kinetics. So kinematics is the study of motion. Looking at motion, to describe any motion, there are three fundamentals that need to be known. This is how far you went, the time and acceleration, so the measure of the distance travelled, how long it took to travel that distance, and how quickly or slowly you sped up. There are three types of kinematics we can measure, so that's displacement and distance, speed and velocity, and acceleration. These are all describing motion, and then motion can be broken down into three types, which is linear, angular, and general. So linear kinematics is all parts of a system move in the same direction and at the same speed. Rectilinear motion is motion along a straight line, and curvilinear is along the curved line. In sport, this could be a straight dive off a dive board, skydiving, or skeleton. In basketball, rectilinear could be running up in a straight line on the basketball court. An example of curvilinear could be cutting left and right to get around the opposition's defenders. So angular kinematics, a system moves in a circular path around an axis, so all parts move through the same angle, in the same direction and at the same time. This could be shown in gymnastics, like performing a somersault, like a front tuck, or a spin on a ball, so maybe in cricket. An example for basketball could be shooting. So general motion is a combination of both linear and angular, which is most common within human movement, and a simple example of this could be running. So kinetics is the study of forces involved or as a result of motion or movement, which can be broken down into linear and angular. Things do not move without a force, so kinetics measures the force, the pressure, the torque, the work, impulse, momentum, and power. Kinetics looks at both linear kinetics and angular kinetics. This describes the causes of motion. So linear involves both rectilinear and curvilinear, looking at forces, gravity, mass, weight, whereas angular kinetics looks at specifically levers. How is the model created? The numerical model can be produced in many ways. Firstly, literature-based, which is by gathering the information needed through books, computers, such as the use of the internet, magazines, and other paper forms. However, a large amount of models are created through athletes, for example, using elite athlete data and then comparing it to your individual in order to improve and see what areas need to be worked on to become more like the elite level athlete and gain data. In addition, just looking at a specific athlete, whereby all the attention and data is specifically about them. This could be one-off select data, same data collected over a season, or data from previous seasons to compare to see what areas have improved and what still needs to be worked on. In order to create the most reliable, accurate model using a combination approach allows the most detailed data to be collected. So, evaluation of the model in practice. There are many advantages and disadvantages of the numerical model. So the advantages are that it is applicable and beneficial to elite level athletes due to the fact it helps to increase performance, as it helps to identify changes that might need to be made in order to improve their performance of the individual as well as the team, as well as change that might need to made regarding equipment. In addition, it helps to reduce the chance of injury. However, on the flip side, there are also many disadvantages of the model. For instance, the numerical model can be very complex with different factors and options to gain different outcomes depending on the numerical model, what it's being used for. In addition, those producing the model must have depth theoretical knowledge and must be able to use the vast amount of mathematics within it. In addition, once the data is collected and being analysed, those receiving the data need a wide range of knowledge to be able to understand figures and graphs to pass it on to the athletes in order to make a difference. Specialist equipment and controlled environments are needed and therefore can become very expensive. Finally, the whole process of producing the numerical model can be very time-consuming, from gathering the data, importing it into various systems to produce graphs and figures, and then developing it and then understanding it as the athlete and putting it into practice. Both linear motion, both scalars and vectors are a type of measurement. However, differ due to the fact a scalar only tells you magnitudes or the size of that measurement, whereas a vector measurement tells you both magnitude and direction. A scalar tells you how big, far, or fast, for example, whereas a vector puts a direction on it, for instance, how fast, up or down. Examples of a scalar could be mass, distance, speed, temperature, time, energy, or inertia. An example of vectors could be displacement, velocity, acceleration, deceleration, weight, or momentum. So here's just a visual of the scalars and vectors. So going into a bit more depth, speed and velocity. Speed is how quickly the body moves and is measured in meters per second and is a scalar. Velocity is how quickly the body moves in a particular direction and therefore, as it's got direction, is a vector. You can see from the equations on the screen that the average speed is the total distance divided by the total time, and for the average velocity you can see it's the total displacement divided by the total time. So distance and displacement. Distance is the sum of all movements regardless of direction. For example, a route a player takes or where a player travels throughout a game. Whereas displacement is the difference between the object's final position and its initial position. For example, where the player started on the pitch and where they finished. To measure displacement, you take the object's final position away from its initial position. Distance and displacement can be the same. For example, in a 100 meters race, the object's distance is 100 meters, and from the object's start position to the end position is also 100 meters. However, they can also be different. This is like shown in the 400 meter race. The distance covered is 400 meters. However, the displacement is 0 due to the fact that the object starts and finishes in the same place, and displacement is always the quickest route. Acceleration. Acceleration is the rate of change of speed and velocity. It is measured in meters per second squared. The equation used to work out acceleration is the change in velocity divided by the time taken. There are two types of acceleration known as acceleration and deceleration. From the 100 meter sprint acceleration time graph, you can see that from 0 to roughly 2 seconds, there is a dramatic increase where the athlete then reaches its peak before a dramatic decrease to their average pace, followed by a slow deceleration until they finish the race. Inertia. Bodies have a reluctance or unwillingness to change their motion. Larger mass have a greater inertia value. So forces. Motion is created by force, either applied force, which is contact known as friction, caused by a person or another object, or gravitational force, whereby no contact is made. This is known as gravity, created by the earth or an attracted object. Force is the strength or energy created by a push or pull. Force is measured in newtons and can be and can be measured in different ways. On the screen shows different types of force and the direction in which the force occurs. So Newton's laws of motion. Newton has 3 laws of motion. So law 1, an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law is often known and called by the law of inertia. In basketball, this could be shown by shooting, whereby the ball is at rest in your hand until the unbalanced force is applied. This is the athlete pushing the ball towards the net. It then travels at the same speed in the air until another unbalanced force is applied. This is gravity, which brings the ball back towards the Earth's core. According to Newton's second law, known as acceleration, acceleration is produced when a force acts on a mass. The greater the force of the object being accelerated, the greater amount of force needed to accelerate the object. His second law gives us an exact relationship between force, mass, and acceleration. This can be shown in the equation force equals mass times acceleration. An example of Newton's second law could be applied by if there's a stationary object that weighs 1,000 kilograms, like this car on the screen. If you try to move the object at 0.0 meters per second squared, using the second law, you can work out the amount of force being applied. This would be 50 newtons because the force equals mass times acceleration. The third and final law is action-reaction. For every action, there is an equal and opposite reaction. This means that for every force, there is a reaction force that is equal in size, but in the opposite direction. Stability and instability. Stability is the measure of how likely an object is to be moved when a force is applied. Stable objects are very difficult to topple over, whilst unstable objects topple over very easily. To maximise stability, having a wide base of support, the lower centre of mass, and keeping the line of gravity within the base of support reduces the chance of an object falling over. For example, in gymnastics on the beam, during the dismount, the gymnast might have to step forward in order to gain balance by widening their base of support. This will stop them from falling over and being deducted less points in the competition. However, sometimes instability is needed and is produced, for example, in diving. This is done by the object pushing a force outside the centre of mass. In basketball, in rebounding, stability is needed to prevent being pushed over by the defender, allowing them to get a better position within the key. This is done by boxing out, creating more stability. One foot is placed further forwards than the other to prevent being pushed and falling forwards, as well as a wider base, having shoulders just wider than shoulder widths apart, as the wider base of support prevents falling sideways if pushed from the side. Method of data collection. Preparing the participant, making sure that they have agreed to take part and are both ready physically and mentally to partake is very important. This can affect their results, and therefore completing a parkour or warm-up and going through the test protocols is vital. Data collection can be measured by force plates. This looks at the force and kinetics. It looks at ground reaction force. Ground reaction force, which is the weight of the object, is the downward force, and the ground reaction force matches it. Cameras can look at the movement and combination. So VidCon is where 3D markers are placed on the object, as you can see in the picture on the left, those white bubbles stuck all over the legs. And then there's cameras around the room, which can then be used, which record and then use the software to be analysed. So, collaboration of the force plates is needed before recording any data. This helps to make the data more reliable, as well as a goniometer can be used to ensure that the participants are at the correct angle. Looking at our personal data collected, you are able to see that our data is inaccurate due to the fact we did not check the angles, and therefore some jumps use more momentum than are supposed to, and therefore the results aren't as accurate as they could be. Allowing participants a chance to familiarise themselves before conducting the actual test helps to remove errors from the final data. For example, when jumping, trying to land back on the force plates, having a few test runs, you get the feel for where you need to land, because if you land half foot on, half foot off, then the data obviously is inaccurate. There are many things to think about when measuring the collected data. So the camera needs to be perpendicular to the jumper, making sure that all the motion is fitted in so that you're able to analyse the data. Knowing how far back the camera is also important when putting the angle zoom into perspective. You want to be as far away as possible and zoomed in. Sometimes a meter ruler is used to get a perspective. The shutter speed, looks at how quickly the image is taken. So the camera settings are really important. Sampling frequency. There's 100 bits of data a second, means more detailed image. However, the frame rate has the same principle as the force plate. Higher rate means better detail. There are some issues with the shutter speed though. The quicker the shutter speed, the little time to allow light in, and therefore there needs the right balance to be found in order to allow the picture to be produced. Horizontal scaling and vertical references. The meter ruler is used at the start of filming to get a scale to ensure that the action is completed where the scale is done. So don't take the scale and then move the camera, because then it would be the wrong scaling. Knowing what you are measuring to set up the camera appropriately is vital.